Established in 1993, but funded since 2010 primarily by a generous endowment from John Wiley and Sons. Parenthetically, let me ask those of you who visit the reception or the exhibit area to stop by the Wiley booth and thank them for their support. The David Halliday and Robert Resnick Award for Excellence in Undergraduate Physics Teaching recognizes outstanding achievement in teaching undergraduate physics, which may include the use of innovative teaching methods. I invite Edward Prather, please, to come to the podium. This summer, the Halliday Resnick Award is presented to Edward Prather, who is on the faculty of the Department of Astronomy at the University of Arizona in Tucson. The citation in the on-site guide for this meeting enumerates several reasons that the awards committee has chosen to recognize Dr. Prather, and I urge you to read about his involvement both in teaching and in assessment of innovative instructional strategies, not only for majors and the general student, but also for pre- and in-service teachers. His teaching engages students, demonstrably improves their understanding of fundamental Earth and space science concepts, and challenges them to step out of their comfort zones, to take chances on being wrong, and to take charge of their learning. I'm pleased and honored to present to you, Edward Prather, the 2011 David Halliday and Robert Resnick Award for Excellence in Undergraduate Physics Teaching. The full award consists of a framed certificate, a check, and a copy of the citation that is printed in the on-site guide. Prather's lecture is titled Teaching Space Science, a STEM Transformation Vehicle That Really Works. Thank you.
Can you hear me well?
Yeah.
Do I need a microphone? Yeah. Okay. I heard what we got. Sorry about that. Better? More? How we doing? Can you hear it at all?
Better.
Okay. Well, first I want to say thank you to the AAPT and the award committee. It's a tremendous honor for me, especially since I teach astronomy. I can't say how this is special to me. I really take a lot of pride in the work that we do at the Center for Astronomy Education, and in the time that I've spent really thinking carefully about my teaching and trying to take risks in my classroom and work with my students, and it just feels great to have some kind of honor bestowed upon me for the work that I love to do. It's hard to follow those two speakers. I feel like maybe the best I can do is say, I'm going to do the same thing. But not like David did. I wish I was. I do a lot of interactive things in my classroom, and I'm kind of glad I didn't try to bring anything, because that's really hard to follow. And now that you're all wearing tie-dye shirts, my colored cards seem a little obscure to try to read while I look at you later too. I work in a collaborative environment that I want to start off by saying thank you to the funding agencies that help me do the work that I do, especially NASA and the National Science Foundation. I work with very large collaborative groups around the country doing research on how people learn in different teaching environments. And this is a list of the collaborative group that's known as CATS, the Collaboration of Astronomy Teaching Scholars. These folks are all working, they're graduate students, postdocs, undergrads, faculty, and the grant that we got from the National Science Foundation that made CATS possible, and if Duncan McBride's in the audience, thank you, Duncan, because he had a lot of foresight into how to create a national collaborative of folks that hadn't been doing any research before, that might all have fundamental questions about their teaching and learning that they wanted to investigate in their classroom. And our program was to elevate the number of people in the space sciences that were doing research on how things were going in their classroom and start developing their own curriculum based on their classroom experiences. And this is a list of some of the folks that have contributed that work. But along with this slide, I want to say I work with hundreds and hundreds of folks around the country on doing research in different classroom environments, from non-science major classrooms and classrooms for teachers and astronomy classrooms. And it's a tremendous honor, and you learn so much working with all these people and getting different perspectives. I'm going to do the where do I come from? But I'm going to start with this slide. That's me. I have weird hobbies that cause you to get metal put in your body. And this is where my physics pathway starts in many ways. I didn't have an expectation that I would go to college. Nobody in my family had ever been to college. I was a blue-collar worker as a crane mechanic and assembly line worker for a living. But along the way, my love of machinery and racing and building race cars and motorcycles made me curious. And I asked a lot of questions of engineers and different people, and oftentimes people would say, that's physics. And in high school, I didn't take any science. I took one health biology course. Otherwise, I was at the local VOTEC taking auto shop classes and learning about how machines worked. And I thought, I'm going to be a mechanic for a living. And I was. And I didn't go to college until I was in my 20s. And this perspective brought me to a community college, where I started off in a class that was pre-algebra. It was literally decimals, fractions, and the number line as my first math class in college. And so I come from very humble beginnings in many ways to get to where I become a physics teacher. And that perspective of not ever thinking I was going to be a physics teacher and being involved in all these other sports and hobbies, I think I draw from every day in my classroom, and I try to share with my students. I think one of the previous speakers talked about helping them feel smart and also helping them realize you can do it. I struggled too. It was just as hard for me, and I totally understand what you're going through. It's one of the most authentic things you can say and be a part of with your students. I graduated with an associate's degree, which let me transfer to the University of Washington. I had still never had a physics class in my entire life. I entered into the University of Washington having declared myself a physics major long ago because I thought it would be cool to know that. It seemed to explain everything I was curious about. Didn't really know what it was. Seemed almost like magic, to be honest. And a really serendipitous thing happened. And I promised a couple people that I was going to thank that I wouldn't put their pictures in my PowerPoint slides. Because I'm going to say some pretty obscure things in the slides to come, and I don't want you to identify their faces with my words later, so I'm going to protect the innocent. And I'll say some names, and you'll be reading some name tags going, is that one of those people that he said earlier? We'll find out. I moved to the University of Washington, and in that shift from the community college to the state university, I ran into the physics education research group at the University of Washington run by Lillian McDermott and folks like Peter Schaefer. And they were running a course in the summer for underprepared physics majors. And I thought, that sounds just like me. And so I took this class, and it turns out it was physics by inquiry. And it was being taught in the summer, and that was my very first physics course in life. And I don't know that you could have a better beginning than a complete inquiry-based course as your first introduction to the entire topic area, as a 23-year-old student for the first time in a science class of that type. And along the way, I got to work with a large fraction of the graduate students that were getting their first PhDs in physics at the University of Washington. And so I'm going to just say thank you to all of them. And thank you to, I don't know who's in the audience, so I don't want to name too many people, but Mike Loveridge was a great TA of mine. Luana was a great TA of mine. Brad Ambrose was a great TA of mine. And I can keep going on and on. I don't know if Andrew Bordeaux is here, who was a great TA of mine. Many of the people who came from that research group in the first years were TAs, all working in the tutorial settings. And they were really helpful, and they were my models as teachers. But I want to highlight three people in particular. Peter Schaefer was one of my TAs. He has this ability in the classroom environment, in the instructional setting, to walk through it and help you as if he's like an ether. And the whole environment is not disturbed, and he's sort of gracious and just kind of moves through the learning environment, and people get better. And I looked at that and I was like, that is an amazing thing this person's doing. Get better. And then I also had another teacher who taught that first course named Greg Francis. And I don't know if you've ever met Greg Francis, but he is a dynamo. And his passion and his desire and his genuine nature inspires you incredibly to work harder and live up to the expectation Greg's setting by his example. And then I also had an opportunity to work with Rand Harrington, who became my thesis advisor. And he has a creativity, and he draws from so many resources and brings them into the classroom and challenges students to embody their learning in so many different ways. And I had these different models of what a teacher is in my first couple years that really framed for me what it is to be a teacher. Along the way, I got to work with the research group there and start to realize, you know what? Maybe what I really want to do is teach. Maybe what I really want to do is do research and teaching too. Maybe I'll get a PhD in this. And luckily, I got the opportunity to work with Rand Harrington after he got his PhD and went to the University of Maine in Orono. And I moved on to get my PhD in physics education research. And as part of that, I was looking for a job. And the job that I found after getting my PhD happened to be in astronomy. While at the University of Washington, to avoid having to leave the physics building, which I loved so much, and not take other science disciplines to get my degree, I got a degree in astronomy. Because because you could get another degree in that, and you didn't have to leave the building. It was just more physics, and what could be better. Never thinking I was going to use my astronomy degree ever in life. It was cool, it was fun. And then I got a job in astronomy. I'm like, gosh, I'm kind of glad I got that astronomy degree back a while ago. That seems pretty convenient. And that move to astronomy has actually defined the rest of my career. While I was working in physics, I got to work with pre-service teachers and in-service teachers in physics by inquiry classrooms. And I spent quite a bit of time in grad school developing a course for non-science majors to teach non-science majors physics. And in many ways, it was much like what Stacy was describing. The whole course was developed as lab first, all investigation-based. The classroom was used to do secondary development beyond their first development of all of their own ideas. And it started making me think about how to develop curriculum. So I want to ask you guys, you all have a piece of paper that you got, or most of you, I hope. I don't think there's quite enough for everybody, but you got a piece of paper. And I do a lot of interactive things in class, and I just want to check with you about a couple things. When it comes to voting, there's 2 rules, and any of you that have been through one of my workshops and know what I'm about to ask you to say out loud, just fill in the blank. Remember, there are 2 rules for voting. Voting needs to be done simultaneously and anonymously. Okay, so when I ask you to vote, please don't vote until I count to 3. And when you vote, don't vote here. Vote right here on your face so I know it's your vote, and only your vote. And I want to set it up. I want to set up a scale for your vote. Let's let A represent. A is, I'm doing pretty good. I'm pretty happy with how things are going. I'm going to give you a thing to vote on in just a second. But A is, things are going pretty well. And B is, it's not going great. I'm a little concerned about things. And C is, I'm really concerned about things. I'm pretty troubled by it, actually. Troubled by it. And D is, I'm on a suicide watch. I'm so troubled by this. And the thing that I want to ask you to vote on is our society. That's why I didn't show anybody's pictures, because that's where I'm headed next. Let's vote on 3, shall we? Our society. Should you be voting yet? Just checking. Okay. 1, 2, 3. Okay, the good news is I'm not seeing a lot of A's. All you D's, I'm sorry, man. It's scary, okay? Most of you are in the B and C range. And for me, this is what I'm most concerned with right now, with what I do in my career, is that I'm living in a society I'm afraid of. And I'm going to talk a little bit about our role as instructors and our role in teaching and what I've been doing over the last 10 years to talk about that. And I don't mean to bring the mood of the room down too bad. It's actually not so terrible. Some great things are happening as a result of taking that perspective. So I teach astronomy because that's where the students are. There's 250,000 students a year taking introductory astronomy, and I work with geoscience folks also. If you couple our 2 together, that number is 500,000 students taking introductory science. I'm at the end of a pipeline, if you will, of these folks. These folks, for the most part, all opted out of science. They're not future scientists at all. 80% of any of the classrooms are typically the non-science major population. So there are 10% of the college population that is just astronomy. It's Earth and Space Science. 20% of all college students take one of these classes as their general education science class. It is their last science course in life. This is it. This is our last chance to try to change their perspective and create advocates and ambassadors in life for what we hope to have a career doing and all of the things that we hope happen. And one of the things to think about is where they end up and who they are. These folks are your future scientists. There's scientists in the classroom. There's technologists in the classroom. But mainly they're artists, lawyers, English majors, business leaders, politicians, policymakers, parents, and voters. These folks matter so much to me that I'm dedicating what I do to change this aspect of our society through this course. Also, there's a lot of teachers there. A lot of teachers there. This is where your pre-service teachers often take their last science course in life too. So how we model the teaching and learning in our gen ed, non-science major courses, serves a great many purposes as to what we hope to have happen in our society. And I just want to try to encourage you to kind of look at what you're doing in your class and think about maybe teaching a gen ed science course and maybe thinking about how that has an effect on what happens in the society you live in. Because you didn't just vote A.